Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about specific gravity and assay. Concentrated commercial solutions of chemicals, called stock solutions, are often described in terms of specific gravity and assay. And those two pieces of information allow us to find the concentration of that solution. Specific gravity is defined as a ratio, and that ratio is the mass of a solid or liquid compared to the mass of an equal volume of water at 4 degrees Celsius. Now, the mass of 1 milliliter of water is 1 gram. So when we are given the specific gravity of a substance, it's that many times heavier, or it's that many times more mass than 1 gram. For example, if a substance has a specific gravity of 1.48, that means that it has a mass 1.48 times the same amount of water, the same volume of water. Therefore, 1 milliliter of this substance has a mass of 1.48 grams because that 1 milliliter of water has a mass of 1 gram. Assay represents the percent purity of that solution. So with the two values, specific gravity and assay, we can use those two values to find the concentration of our particular chemical or substance in that solution. Let's take a look. In this example, the values listed on the label of a bottle of nitric acid are a specific gravity, and you'll see SPGR as a symbol for that, 1.24, and assay, or percent purity, 70%. Find the concentration of the solution. So we know that 1 milliliter of the solution will have a mass of 1.24 grams because of the specific gravity. It's 1.24 times heavier than water. And an assay of 70%, or a purity of 70%, means that 70% of this mass is nitric acid. Therefore, we can find the amount of nitric acid in 1 milliliter of solution by taking our specific gravity of 1.24 and multiplying it by 70%. And in order to multiply by 70%, we need to change it to a decimal. So 70% is 0.7. We simply divide by 100. When we multiply those two together, we get 0.868 grams. Therefore, the concentration of nitric acid in that solution would be 0.868 grams per milliliter. So when you have those two pieces of information, you can use them in this manner. Take your specific gravity, multiply by your percent after changing the percent to a decimal, and that will give you your concentration in grams per milliliter. In the next example, we have a specific gravity of 1.38, an assay or percent purity of 92%. So in order to find the concentration, we start with the specific gravity, 1.38, and we multiply that by 92%. 92% as a decimal is 0.92. And we get 1.2696. The unit will be grams per milliliter. Always grams per milliliter, because we're comparing to water. Water has a mass of 1 gram per milliliter, and this is 1.38 times heavier, and this is the purity of that substance. Often when you do work with those commercial chemical solutions, you're going to be diluting them into working solutions, and in order to do that, we have to understand changing concentrations. So let's talk about that. If you're doing any work with changing concentrations, you're going to see the formula C1 times V1 equals C2 times V2. And I just want to explain that formula a little bit first before we start doing examples. When we're talking about concentration of a solution, we're talking about the ratio of the mass of the solid to the volume of the solution. And I can rearrange that formula by just multiplying both sides by volume to isolate mass. So mass will be equal to the concentration times the volume. So when you dilute a solution, you're taking a certain volume of that solution and you're adding a diluent such as water. When you dilute it, the mass of the solute stays the same. you still have the same amount of solute because you're not adding any more solute, you're just adding solvent or diluent. So because the mass doesn't change, and because mass represents concentration times volume, the mass in your first solution will be equal to the mass in the second solution, or the concentration times volume in your first solution will be equal to concentration times volume in your second solution. That is an inverse proportion. In inverse proportion, as one value goes up, the other value goes down. So as we increase the volume from what it was, because that's going up, the concentration has to decrease. Let's take a look at using this formula with examples. In this example, we're asked to make 1.25 liters of a solution which has a concentration of 10%. This does not refer to percent purity. This is actually a unit to express concentration. It means 10 grams per 100 milliliters. So we want to make a solution that has this concentration, and we're using a supply that has a specific gravity of 1.38 and an assay of 92%. So we need to know how much of that supply solution do we use to get 1.25 liters of a 10% working solution. What I like to do is outline each of these values and make sure that the units are consistent with each other, and then it gives me a good idea of what my unknown is. So when I do C1, V1, I typically use that as your supply solution, and I use C2, V2 as your working solution. So our supply solution, C1, is equal to, I find the concentration of the supply by taking the specific gravity, 1.38. I multiply it by percent purity of 0.92. And we found that in the last example, 1.2696 grams per milliliter. V1 is what we're finding. We want to know how much of the supply solution do we need. Now, if my concentration is in grams per milliliter, I need my volume to be in milliliters. We want to be consistent with our units. Now we're going to look at the working solution. What do I know about it? I know that I need concentration, so C2 is 10%. I can't leave it in that form. I need to have it in the same units as this concentration, so I want it in grams per milliliter. So first of all, 10% means 10 grams per 100 milliliters. I talked about that in a previous video when I talked about what percent concentration means. And I don't want to leave it in that form. I want it in grams per milliliter. So I'm going to divide by 100, and I will get 0.1 grams per milliliter. The volume of the working solution is I want to make 1.25 liters. If my concentration is grams per milliliter, I want my volume to be in milliliters, so we're going to multiply by 1,000. So 1,250 milliliters. Now I can put these values in this formula. C1 is 1.2696 grams per milliliter. V1 I don't know, that's going to be my unknown, will equal C2, which is 0.1 grams per milliliter, times V2, which is 1,250 milliliters. I like seeing the units there because it keeps students on track, making sure the units are consistent. But when I do the math, I'm going to ignore the units now that I know that everything's consistent. So in order to solve for V1, I'm going to multiply 0.1 times 1250, and then I'm going to divide by 1.2696, and I get an answer of 98.5. I know it's a volume that has to be in milliliters, so 98.5 milliliters. Let's do another example. In this example, it asks us to find the concentration of a solution which is prepared by diluting 25 millimeters of an 85% pure acetic acid solution that has a specific gravity of 1.42 up to 300 milliliters with water. So we're going to do this example the same way we did the previous example. we're going to use C1 times V1 equals C2 times V2. We're diluting it, so we are changing the concentration. And our stock or our supply solution has a concentration of, we take specific gravity, 1.42. We multiply by the Assay, which is 85%, as a decimal is 0.85. And that gives us 1.207. The unit will always be grams per milliliter. When you're taking specific gravity and multiplying by Assay, unit is always grams per milliliter. We're taking 25 milliliters of that supply solution. Now let's take a look at the working solution. Concentration, we do not know. But I'm going to want it or get it when I put it into the formula in grams per milliliter. Volume 2 is 300 milliliters. So we're diluting it up to 300 milliliters. So I know all my values except for one. I can plug into my formula. C1 is 1.207 grams per milliliter times V1, which is 25 milliliters, will equal C2, I don't know, times 300 milliliters. Again, I know that my units are consistent, so I'm just going to ignore them. In order to solve this, I'm going to take 1.207, multiply by 25, divide by 300. To get a concentration of 0.1006, I know my unit is grams per milliliter. So I've diluted it. The concentration was this. It's now this. I'm going to do this question another way, and it ties back to what I did in a previous video on dilutions. And I want to use the formula I talked about there because you might find it a little bit easier. We know the concentration, the original concentration of our solution. It will be equal to 1.42 times 0.85, which was 1.207 grams per milliliter. Because we know both volumes, I can find the dilution factor. In that video, I talked about this formula, the original concentration of a solution, multiplied by the dilution factor will give you the final concentration in the same unit. So if we have 1.207 grams per milliliter, the dilution factor can be found using these two volumes. If I'm taking 25 milliliters and diluting it to 300 milliliters, that's a dilution factor of 25 to 300. When I take 1.207 and I multiply by 25 over 300, I get the same result. And my final concentration will be in the very same unit as the original concentration. So you can do this question both ways. When you know both volumes, you can do it as a dilution using this formula, or you can always rely on C1V1 equals C2V2. The concentration of a solution can be measured in a number of different ways. It can be measured with specific gravity and Assay. It can be measured as a percent or expressed as a percent. It can be expressed as molarity. It can be expressed as normality. And there's other concentration units as well. I want to do more examples on changing concentration with a variety of those concentration units. So the next video is going to be more examples. See you then.